y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good I here. I don't want to assign y to x if x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have three conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run Python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look, perhaps, at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic. And more technically, it shows the program's control flow. That is, the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flow chart. And you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape. And inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2, respectively, for x and y. So, of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask two more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question, and this flowchart captures that as well. The third diamond asks x equals y. Now, that too has a false answer in this case, because 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answered the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code that you write to be correct and do what you intend. Longer term, especially as our programs get longer and more sophisticated, more complicated, we're going to want them to be well designed too. Thoughts on in what way this program is arguably not well designed, even though it's correct? Let's see here. Khalid, if I'm saying that right, your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this, if this, if this, and yet logically, I should know the answer to some of those later questions once I figure one out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking three questions. No matter what, all of those arrows lead to the first, the second, and the third diamond. So I'm asking three questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this too is kind of a succinct one. It's a conjunction of else if in English, which allows us to ask a question that takes into account whether or not a previous question had a true or false answer. Well, what do I mean by that? Well, let me go back to my code here, and let me propose that we now improve upon this here by asking ourselves, ultimately, how can we ask fewer questions? And let me go ahead here and propose that instead of asking if, if, let's make these conditions potentially mutually exclusive. That is to say, don't keep answering questions once we get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, if x greater than y, if x equals y. So I'm going to implicitly, just like in English, take into account that I'm only going to keep asking myself these questions if I haven't yet gotten a true response. Think about the logic here, the English. If x is less than y, on line 4, print out x is less than y. Well, if that's the case, you're done logically. Because if the English is saying if x less than y, else if x greater than y, those are going to be mutually exclusive if the answer to the first question is true. You don't have to keep asking questions to which you already logically know the answer. So let me go ahead now and run this program. And I think the behavior is going to be the same. Python of compare.py, what's x? Let's do 1. What's y? Let's do 2. X is less than y. Now, honestly, I didn't really notice a difference when I ran the program. And honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs. But it's laying the foundation for writing better code longer term. Now, what is the improvement I've just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what. Even if I already figured out what I want to print on the screen, this new version of the program that has if, elif, might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here. But let's focus on just how many questions are getting asked. Let me zoom in at the top as before. And let me propose that we note that the start oval is at the very top. And it's asking us to ask one question first. X less than y. Is 1 less than 2? But notice here, let me zoom out. If 1 is indeed less than 2, we follow this longer arrow down marked true. We print out, quote unquote, x is less than y. But then we immediately follow this next arrow down to the icon that says stop. So that's what's implied by doing if, elif. If we get back a true answer right away to that first if, we're going to print out x is less than y and then stop. We're logically at the end of the program. So this picture is just representing graphically what the code is actually doing. But suppose I typed in something else. Suppose that my code actually ran and I typed in 2 for x and 1 for y. That is to say, the answer to the first question is now false, but the answer to the second question is now true. Because, of course, 2 is greater than 1. Well, let's go back to the diagram. Same as before. We start at the very top where it says start. The very first question up here now, x less than y, is an answer of false because no, 2 is not less than 1. So we follow this arrow to the next question, this diamond. Is x greater than y? Well, yes. 2 is greater than 1. So now we follow this left arrow, which is true. We print out, quote unquote, x is greater than y, and then stop. So what's the improvement? Well, in the first case, we got lucky and we only had to ask one question and boom, we're done. This time we had to ask 2 questions, but then boom, we're done. Only if x happens to equal y do we actually find ourselves logically getting all the way down to this final elif in my code. And pictorially, only if x is equal to y do we find ourselves going all the way down to the third diamond, the third question, asking is it equal to y or not. Now, hopefully the answer at that point is not false. We've included a false arrow just so that the program itself is well defined. But logically, we shouldn't actually be getting there anyway, because it's got to be less than or greater than or equal to in this case. Well, let me pause here to see if there's any questions now, either on the code version thereof here or on this diagramming of that very same logic. Questions here on this control flow?
Aren't we supposed to put an else at the end?
A good question. And yes, so that's going to be my third and final approach. And if you don't mind, let's pivot there right away. Identifying a third keyword that indeed exists in Python that allows us to be even better at expressing this logic, to design this program even better. And that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, elif x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore, because logically, if the two conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first two scenarios, logically, it's got to be the case that x must equal y if it wasn't the case that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here. And instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else, just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice that it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. Still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1. And it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, elif in place, looked a little something like this. And notice that, again, we might have asked one question or two, or worst case, 3 whole questions. But we can do better than that. Using else, as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less likely you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here. And let's propose how we might ask a couple of questions at once this time. Perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine, is x equal to y or not? Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y or x is greater than y, let's go ahead and print out x is not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, it's obviously not equal. So we can conclude x is not equal to y. So if we instead want to make sure that it is equal to, we can just use Hope's else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run Python of compare.py. What's x? 1. What's y? 2. OK, x is not equal to y. Let's do it again. But 2 for x, 1 for y. X is not equal to y. And one third time, how about x is 1 and y is 1? X is now equal to y. Now, if we want to compare that visually to, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but it's a pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false. So we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture just as we have lines of code. And then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I could improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? Could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is just equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw in the available list earlier. We can check not just less than or greater than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's less than or if it's greater than? Well, if all you care about is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that, too, I think is going to work exactly the same. But the picture now looks a little bit different. Notice that this was our flow chart earlier that represented that same logic. And there's a bit of complexity. You got to go left. You got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler, perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question. Is x not equal to y? And if so, true, we go ahead and print out x not equal to y. If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you. We could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct. But now the diagram, instead of looking like this, is going to change the not equal to equal equal. And we just need to make sure that we print out the right thing accordingly. And again, here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who have been programming for years might not necessarily be in the best habit of indenting your code properly. And one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here. And indeed, it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks instead. It relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts. And that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose here that we explore this kind of logic by way of another program altogether in VS Code, whereby I'll go ahead now and create a new program, say, called grade.py. Let's consider exactly what grade a student should get based on their score on an exam or a test or a quiz or some other assignment like that. I'm going to go ahead and run code of grade.py to give myself a new file. And I'm going to go ahead and start by just getting the user's score, again, on some assignment or test or the like. And I'm going to store it in a variable called score equal the return value of the int function, which is going to convert whatever the user's input is when prompted for this score. So again, the user should just oblige by giving me a number like 0 or 1 or 2, or hopefully much higher than that, like 97, 98, 99, 100, assuming the test or assessment is out of 100 percentage points. Now, how could I go about assigning a grade to the student's score? Well, in the US, it's very commonly the case that if you get between a 90 and 100, that's an A. And if it's between an 80 and an 89, it's a B. If it's 70 and 79, it's a C, and so forth, all the way down to F, which should be E, but we'll see that there's a bit of a jump. So how might I express this? Well, I can use conditionals, and I can ask a few questions and then print out the student's grade accordingly. So let me express it like this. If the student's score is greater than or equal to 90, and the student's score is less than or equal to 100, so it's in that range, let's go ahead and print out that their grade shall be an A, because they're in the 90s above grades range. If the score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways. And maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the student a B if it's in the 80s. If score is greater than or equal to 70 and the score is less than 80, I'm going to go ahead and give them a C. If the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade. So that's the catch-all. And I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D. Else, it's going to assume that you got an F. Well, let's try just a few of these here. Let's run Python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time. Maybe it's a 95. Still an A. Starting to slip further, so I got an 89 the next time. That's now, say, a B. And let's say I really had a bad week and it's now like a 71. That's now a C. Or I didn't even submit it at all. That's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong. It's correct. And indeed, according to my own specifications, I dare say this code is correct. But can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90. But I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score. And here, 70 is less than or equal to score. And then lastly, 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score, and is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper, pencil in the real world, you can encode in Python do this, which is just a little cleaner, right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further and just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like, if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions. But again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditionals, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run Python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I'd kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary, but yes, there's absolutely other ways to do it, but I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too, to just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before, this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0 because it divides cleanly. 4 divided by 3 has a remainder of 1 because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark. And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear, a number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers. But it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote unquote even and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer. So I'm going to go ahead and print out quote unquote odd instead. And let's go ahead and now run Python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd. And so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program. And I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark. And then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven. And I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote unquote even. So if this magical function called isEven returns true as its return value, I am going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist. And this program would break if I ran it right now. But that's OK. I have the ability, recall, to invent my own function. So let me define with def a function called isEven. I want this function to take an argument, and I'm going to call it n, just a number generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n %2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n %2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, if it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and is even, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more. What's x? How about 3? And it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this question for me that I can now use in this program and heck, maybe future programs that I write, I now have a function that no one gave me, I gave myself, that I can use and reuse. And I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using a conditional up there, and my Boolean expression, something that's true or false, is going to be not something explicit like x less than y or y greater than x or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's OK because I know, because I wrote it, that that function isEven returns true or it returns false. And that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now on how I've implemented isEven using this bool.
Hello, hi David. First of all, thank you for this wonderful class. Day before yesterday and today itself. I have just one query, like basis on my background of Java. There, when we used to pass the arguments, we can also pass the address of the variables. So is there any sort of this concept in Python?
Short answer, no. Those who are unfamiliar with Java or other languages, or C or C++, there's generally ways to pass values in different mechanisms that allow you or disallow you to change them. In Python, no. Everything we're going to see is actually, in fact, an object, but more on that down the line. How about time for one more question here on these bools and these isEvens?
So I actually had a question about defining a function, if that's OK.
Sure.
So if you define one, are you, like within your code, like you made it up, are you allowed to use the dot operator like we did name.strip and use it like that?
Good question. If you've created your own function, can you use other functions like .strip or .title or .capitalize that we've seen in the past? You can use those on strings. Those functions come with strings. You can't necessarily use them on your own functions unless your function returns a string. For the examples you gave, I'm returning a bool. Bools have no notion of white space to the left or the right. You can't call strip. You can't call capitalize. But if you were writing a different function that returns a string, absolutely, you could use those functions as well. Well, let me turn our attention, if I may, back to this example here and consider, as we now frequently do, can we improve on the design of this code? Can I make this particular program better? And I can. There's a couple of ways here, and I'll show you something that's now generally known as something Pythonic. There's actually this term of art in the Python world where something is Pythonic if it's just the way you do things in Python. Which is to say, we've seen already there's so many different ways to solve certain problems. And in the Python community of programmers, there tend to be some ways that are smiled upon more than others. And they tend to relate to features that maybe only Python has, but not other languages. And here's some syntax that you might not have seen in languages like Java or C or C++ if you've programmed before. And if you've never programmed before, this too is going to be new. Instead of asking a question like this, if else, using 4 lines, in Python, you can actually collapse this into just one more elegant line, if you will. Instead of asking if n divided by 2 has a remainder of 0, return true, else return false, let me delete all of that and just say this. Return true if n divided by 2 has a remainder of 0, else return false. Now, those of you who do have prior programming experience might actually think this is kind of cool. You can condense from 4 lines into 1 line that very same thought. And one of the reasons why Python is popular is that it does tend to read rather like English. It's not quite as user-friendly as most English or most human languages, but notice now the line does rather say what you mean. Return true if n divided by 2 has a remainder of 0, else false. I mean, that's pretty darn close to something you might say logically in English, be it about even and odd or really anything else. So that program is going to work exactly the same. Python of parity.py, let me type in 2, it's still even. Let me type in 3, it's still odd. But I can refine this even further. And again, consistent with this idea of not just writing correct code, but writing better and better code, but still keeping it readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0 or not? Like, that is by definition a Boolean expression. It has a yes, no answer, a true, false answer. Well, if your Boolean expression itself has a true or false answer, why are you asking a question in the first place? Why ask if? Why say else? Just return the value of your own Boolean expression. And perhaps the tightest version, the most succinct and still readable version of this code would be to delete this whole line, Pythonic though it is, and just return n modulo 2 equals 0. If it helps, let me add parentheses temporarily, because what's going to happen in parentheses will happen first. N divided by 2 either does or does not have a remainder of 0. If it does, the answer is true. If it doesn't, the answer is false. So just return the question, if you will. You don't need to wrap it explicitly with an if and an else. And in fact, because of order of operations, you don't even need the parentheses. So now this is perhaps the most elegant way to implement this same idea. Now, which is better? This is pretty darn good. And it's hard to take fault with this because it's so very succinct. But it's perfectly OK and just as correct to have an if and then an else, even though it might be 4 total lines, if that helps you think about your code more clearly and it helps other people reason about it as well. So it turns out there's another syntax that you can use to implement the same idea of a conditional, whereby you do something optionally based on the answer to some Boolean expression. And the keyword that you can now use in recent versions of Python is called this, match. Match is a mechanism that, if you've programmed before, is similar in spirit to something called switch in other languages. For instance, let me go ahead here and close out parity.py, and let me go ahead and create a new file called house.py. And in house.py, I think what we're going to do is try to implement a program that prompts the user for their name and then just outputs what house they're known to be in the world of Harry Potter. So for instance, let me go ahead and do this. Let me give myself a variable called name, set it equal to the return value of the input function, and I'll say something like, what's your name, ? And then after that, I'm just going to use a traditional if else construct to decide what house this person is in. So let me say if name equals, say Harry, as in Harry Potter, well, let's go ahead and print out Harry's house, which is Gryffindor in the world of Harry Potter. If the name is instead Hermione, then go ahead and print out also, quote unquote, Gryffindor, as she's in the same house too. If name equals Ron, let's go ahead and similarly print out Gryffindor, quote unquote. And let's make this a little more interesting now. Elif name equals quote unquote, how about Draco? Draco Malfoy in the books. Let's go ahead and print out quote unquote Slytherin. And just in case someone else's name gets inputted for now, let's just suppose that we don't recognize them and say, by default, else print out, quote unquote, who? Question mark, just to convey that we don't actually have a hard-coded response to that particular name. Let me go ahead now and run this as Python of house.py, enter, and I'll go ahead and type in something like Harry. And voila, we see that Harry is indeed in Gryffindor. Let's run it one more time, Python of house.py. Let's type in Draco this time, Slytherin, and now let's type in an unrecognized name. Let's go ahead and rerun Python of house.py, and let's go ahead and type in Padma, enter. And who? Because we haven't actually hard-coded with an elif condition in this case what house Padma is meant to be in. All right, well, it turns out there's other ways to implement this. Indeed, there's some redundancy here in that we're checking if Harry or Hermione or Ron are all in Gryffindor. I feel like we can at least tighten this code up a little bit using techniques we've seen already. So let me go ahead and do this. Let me go up here and instead do something like this. Let's get rid of these two blocks of elifs, leaving just Harry's for a moment. And let's use that or keyword again and say or name equals quote unquote Hermione, or name equals quote unquote Ron, thereby consolidating all three cases, if you will, into just one if statement. Then we still have a separate elif for Draco because he's not in fact in Gryffindor, and then the final else to catch anyone else. All right, let me go ahead now and run this version of the program, Python of house.py. I'll type in Hermione this time. She too is still in Gryffindor. Let me try it with Ron, and that too still seems to be correct. Well, it turns out there's another approach altogether that can perhaps make your code a little less verbose. You could imagine how complicated this code might get if we had not just Harry and Hermione and Ron, but a whole bunch of other names as well for Gryffindor, for Slytherin, and for all of the other Hogwarts houses. So you could imagine that code just getting pretty unwieldy pretty fast. Well, it turns out another technique you can use is indeed this keyword called match, which is very similar in spirit, but the syntax is different and allows you to express the same ideas a little more compactly. So let me go back to house.py and let me propose that I get rid of my current if, elif, else approach and instead do this. Literally use the keyword match and type the name of the variable or value that we want to match on. And then I'm going to go ahead and include a colon. And then underneath that, I'm going to include literally a keyword called case. And the first case I want to consider is going to be Harry. And I'm going to put Harry in quotes because it's a string or a stir. And I'm going to have another colon at the end of this line. And indented under that one, I'm going to go ahead and, for now, print out Gryffindor, which of course is Harry's house. Otherwise, I'm going to have another case for quote unquote Hermione. And similarly, I'm going to have under that indented print quote unquote Gryffindor, close quotes. Now I'm going to have another case for Ron, also in quotes with a colon. Now print quote unquote Gryffindor. And now I'm going to have other case for, let's say, Draco. This one gets a little more interesting because Draco, of course, now is in Slytherin. And then I'm going to go ahead and leave it as that for now. So let me go ahead and save this file and go back down to my terminal window running Python of house.py, enter. And let's go ahead and try Harry. And he seems still to be in Gryffindor. Let's run it again for Hermione. Enter. Gryffindor. Let's skip ahead to Draco and type in Draco's name. He's indeed in Slytherin. Now let's try another name that we haven't handled a case for, like Padma again. Enter. And we're just ignored. There's no output whatsoever because there wasn't a case for Padma. Now, we could, of course, go back in and explicitly add one for Padma. But what if we, similarly to the else construct, just want kind of a catch-all that handles anyone whose name is not explicitly specified? Well, it turns out the syntax for that, using this new match statement, is to still have another case, but then to use this single underscore character, which is used in other contexts in Python. But for here, it's meant to say whatever case has not yet been handled, go ahead and print out, as we did before, for instance, quote unquote, who, with a question mark at the end. Now let's go ahead and rerun this. Python of house.py. I'll type Padma's name again, and this time I think we're at least going to get an explicit response indicating who, whereas previously we did not have the equivalent of that. Now, I think we've regressed a little bit. We went from tightening things up by putting Harry and Hermione and Ron all in the same line in the same if statement. But here we have now three case statements again for all three of those. Well, we can tighten this code up as well, but the syntax is going to be a little bit different. I'm going to go ahead and delete these two middle cases for Hermione and Ron, And then up here next to Harry's name, before the colon, I'm going to go ahead and use a single vertical bar and then a quote unquote Hermione. Then another single bar and do quote unquote Ron. And this is how, using this relatively new match statement, you can say the equivalent of Harry or Hermione or Ron, but more concisely than you could using an if statement alone as we implemented it previously. So now one final run of the program with Python of house.py. Let's make sure that Harry's still in Gryffindor. Let's make sure that Hermione's still in Gryffindor. Let's make sure that Ron is still in Gryffindor. And indeed, all three of them are. Now, as always with Python and programming more generally, there's going to be different ways you can solve these problems. This is just another tool in your toolkit. Arguably, it has tightened things up. Arguably, it's perhaps a little more readable because there's a little less syntax going on, a little less duplication of equal signs and elif and elif and elif all over the place. But ultimately, this would be an equally correct approach to that same problem. But it turns out with the match statement, you can do even more powerful forms of matching as well. Here, we've used it simply to implement the same idea as that if, elif, else construct. And it's worth noting, if you've programmed in some other language, the syntax here is indeed correct. You do not need, for instance, a break statement, as has been peppered throughout. And you don't need something like default or something explicit. You indeed just use this underscore as your catch-all at the end of the match. So just by adding in some of these new keywords here, like if and elif and else, we have now the ability to ask questions about values. We have the ability to analyze input from users and ultimately make decisions about it. And these then were our conditionals. Lying ahead is going to be the ability for us to not only use functions and variables and also these conditionals, but also next loops, the ability to do something now again and again. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on loops, this ability in Python and a lot of other programming languages to do something again and again, a cycle of sorts. And let's see if we can't begin by motivating exactly why we have this ability to do things cyclically using these loops. I'm going to go ahead here and open up VS Code. And in my terminal window, let's go ahead and create via code cat.py, a Python program that meows like a cat. And I'm going to go ahead here in this code tab. Very simply, perhaps, I'm going to start by implementing this cat just by using print. We're going to have this cat not make audible sounds, but just print meow, meow, meow on the screen 3 times. Well, I think the simplest way I can do this is just to print meow once, and to print meow again, and to print meow one last time on the screen. And now let me go down to my terminal window. Let me run Python of cat.py, enter, and meow, meow, meow. All right, so this program works. This program indeed works if my goal is to get the cat to meow 3 times. And let me propose, just to help us wrap our minds around what's going on inside of the computer, let me propose that we consider this flowchart. So as before, we have this flowchart that starts with a this oval, which just means start reading here. And then notice it goes via arrows to a meow, 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 and then it stops. It's perfectly correct, and honestly, it's wonderfully simple, but I dare say we can find fault with my code nonetheless. Why is my code arguably poorly designed? Now, the answer is going to be loops in some way, but let's see if we can identify in what way the code is actually poorly designed in some sense. Let's see. Any thoughts, Alex?
Okay, so I mean, repeating the same action like 3 times or even more is not a good habit.
Yeah, I'm just repeating myself. And honestly, it's not that big a deal. If we go back to my code here, am I really doing such a bad thing by just printing meow, meow, meow 3 times? Not really, but let's consider the logical extension of this. Suppose I wanted to meow 4 times, or 5 times, or 50 times, or 500 times. Do you really think, even if you've never programmed before, Is the solution to this problem really going to be to hit copy paste 50 times? Like, probably not. We can probably do better than that. And beyond it just being ugly at that point, having so many lines of identical code, just imagine if you wanted to change the code. Maybe I changed my mind and I don't want to make a cat, I want to make a dog. So now it has to say woof, woof, woof multiple times. Now I have to change that in like 50 different places. And yeah, sure, I could do find and replace, but come on. Like, we're programmers now. There's got to be a better way than just repeating ourselves. So I bet we can do better than that if we think about a little harder how we go about structuring this program. And we can do that if we augment our vocabulary just a little bit. It turns out in Python, and in other languages too, there's a keyword called while. And while is one way that we can express what's called a loop, a block of code that's going to do something again and again and again, 0 times, 1 time, 2 times, 50 times, as many times as we want. But while rather leaves to us the particulars of how we express ourselves to do something again and again. So let me go back over to VS Code here, and let me propose that I do this. While is a construct that allows me to ask a question again and again. And anytime we've seen a question, it's been in the form of a Boolean expression, a question to which the answer is true or false. Well, how could I do this? How could I print out meow 3 times and ask 3 times a question to which the answer is true or false? Well, what if I did some counting, right? Like literally on my fingers. And if I'm trying to count maybe down from 3, I want to meow 3 times. I can put 3 fingers up and I can meow. And then I can put like one of the fingers down and then meow. And I can put one of the fingers down and I can meow, put one of the fingers down. And maybe the question I can ask every time I meow is, do I have any fingers up still? Do I have any fingers up still? Do I have any fingers up still? And if the answer is true, keep going. If the answer is false, stop. So how can I translate that to code? Well, once we've added this while keyword, I think we have all of the building blocks already. Let me propose that I do this. Let me propose that I give myself a variable. And I'll call it I for integer, but I could call it anything I want. And I'm going to initialize it to 3. Then I'm going to use this new feature of Python, while, and I'm going to ask a question, the answer to which must be true or false. And I'm going to say, while I does not equal 0. So I'm going to ask the question, while I does not equal 0, do the following. Notice the colon at the end of the line. Notice my indentation. And just like with functions, just like with conditionals, you indent the lines that you only want to execute as part of this other thing. What do I want to do while I does not equal 0? Well, I think I just want to meow. But it's not enough just to write this code. If I were to very dangerously run Python of cat.py and hit enter right now, what might happen on the screen? Whether you've programmed before or not. Why is this a very bad thing potentially? It's not going to break things, but it might lose control of my computer somehow. Any thoughts? Yeah, Timo?
Hi, I think it's going to continue to print out mail since I is always equal to 3 and the while is always true.
Yeah, exactly. If I'm initializing I to 3, that is setting it equal to 3 on line 1, then I'm asking the question, while I does not equal 0, and that's going to be true. It does not equal 0. It obviously equals 3. Print meow. And the way a while loop works is that the Python interpreter just keeps going back and forth. It goes from line 1 to line 2, then to line 3, and then it goes back to line 2 to ask the question again. If the answer is still true, it goes to line 3. It then goes back to line 2. If the answer is still true, it goes back to line 3. And to Timu's point, if you're never actually changing the value of I, it's always 3, you're just going to be looping literally forever. And this is an accidental infinite loop. So we've got to be smarter than that. And I'm not going to hit enter because I don't want to lose control over my computer here such that it's printing out meow forever. Fortunately, if you ever do that and you find yourself in an accidental infinite loop, Control-C for cancel or interrupt is going to be your friend. If you ever seem to lose control, you don't need to like reboot or turn off the computer. You can just hit Control-C in your terminal window and that will likely fix it. All right, well, what do I want to do then after meowing each time? I think what I'd like to do here is maybe something like this. Let me update I to equal whatever the current value is minus 1 here. Whoops, sorry, minus 1. So if I, on each iteration, am updating I to be 1 less, 1 less, 1 less, it should eventually hit 0, at which point the answer to 9.2's question will now be false. So let's see if this works. I'm going to go down to my terminal window and run python of cat.py, and I indeed get 3 meows. Why? Because I've kind of wired this up, kind of like a machine in software, if you will. I've set I equal to 3, then I keep asking this question. But I keep turning the gears. I keep changing the value of the variable to make sure that ultimately it is actually being decremented, that is, decreased by 1 until we eventually hit 0. Now, for those of you who think a little more graphically, let me pull up one of our usual flowcharts. This is just a representation graphically of the exact same thing. Notice what's happening. I first start the program, and then I initialize I to 3. And then I ask the first of my questions. Again, the diamonds always represent questions. And the answer is going to be true or false. Does I not equal 0? Well, it doesn't. It equals 3. So if I follow the true line, I meow. And then I follow this arrow. And I update I to equal I minus 1. At this point in the story, I presumably equals 2 mathematically. I follow the arrow. And there's the loop. This is why it's nice to see this graphically, perhaps, because you can literally see the loop back and forth. Now I ask the question again. Does 2 not equal 0? Well, it does not equal 0. It's 2. So we meow again. We change I from 2 to 1. Well, does 1 not equal 0? Well, obviously, 1 is not 0, so we meow again. We decrement I again. I is now 0. Does 0 not equal 0? No, it equals 0. So the answer is false, and we stop. So there, perhaps more so than any of our flowcharts before, do you really see the structure of what's happening inside of the program? And you don't have to get into the habit of making these charts or creating these charts, but just as a first pass at what's going on inside of the computer, that's indeed one way to visualize it instead. Well, let me propose that, like always, there's many different ways to solve this problem. And suppose you just like to think a little differently. Maybe you don't like starting at 3 and then counting down to 0. Why? Maybe your just brain doesn't work that way and you prefer to count up instead of down. Totally fine. Let me go ahead and change my code here to set I equal to 1 instead of 3. And here, let me just change my logic. Rather than checking for not equal to 0, like maybe you don't like thinking in terms of not because it's a little confusing, and it might be, let's just check that I is less than or equal to 3. So we'll be a little more explicit. We'll count from 1 up through 3, each time printing meow, but I'm going to need to change this line here. Let me see if we can't call on someone to change line 4 for me. How do I want to change line 4? To be consistent with counting from 1 up to and through 3.
I would be plus 1 every time you meow.
Yeah, exactly. In this case, we want to add 1, not subtract 1. And in fact, if you think about this, this too could end very poorly, right? If you start counting at 1 and you keep subtracting 1, subtracting 1, subtracting 1, I think we're going to find ourselves with the same problem, which is that we're never going to stop because we're going to keep getting more and more negative as opposed to ever getting up to the number 3. So I think you're right. I need to change this to be I equals I plus 1. And now notice, just for clarity too, the equal sign is, again, our assignment operator from right to left. Logically, this might otherwise strike you as strange. Like, how can I equal itself plus 1? Well, it doesn't until you execute this code from right to left. You add 1 to I, or you subtract 1 from I, and then you update the value of I on the left. The assignment copies the value from the right to the left. Well, how else might I do this? Well, I will say that most programmers, computer scientists more generally, tend to start counting from 0. It's a convention, and it actually has upsides even in Python and other languages where, generally speaking, it's a good thing to start counting from 0 instead of counting like we might in the real world from 1. Let's go ahead and adopt that convention now. Let me set I equal to 0, and I need to make a change now. Notice, if I don't change my logic, this program just became buggy. The cat has a bug. It's now meowing 4 times if I run it as is. But the easiest fix here would be to change my inequality to be this, less than, instead of less than or equal to. Now, I'm starting at 0, but I'm going up 2, but not through 3. And even though this might Of all the things we've seen thus far, see maybe the least familiar. Most of us might start at 1, 2, then 3. It's a good habit to get into now. Start at 0 and go up to, but not through the value that you care about ultimately, 3 in this case here. Well, let me tighten things up a bit here. Not only will this now fix my counting problem, it now meows 3 times as expected, there's a more succinct way to express I equals I plus 1. And this is because it's such a popular thing to do in code. You can instead just say I plus equals 1. And that's it. You don't need to put everything on the right-hand side. This is a special syntax that says the exact same thing, increment I, but it does it with a fewer keystrokes. It's just a little more pleasant to type. It's a little faster to read. It's just a convention. Those of you who have programmed in C, C++, not Python, C, C++, Java, JavaScript might have seen ++ before or minus. Sorry, Python doesn't have it. So you cannot use that. This is as succinct as your line of code might get. All right, let me pause here to see then if there's any questions about these implementations of while loops.
Can we use stuff like for loops, which have a certain I value initialized to it at the start, and it runs from the particular condition you put into the thing and increment it as you go along?
Short answer, no. You cannot do what you're describing, but there is another type of for loop that we will soon see. But let's come to that in just a moment. Other questions on loops using while here?
So I had a question about the flowcharts.
Okay.
There were certain symbols for the certain kind of the statements. So are they certainly used for that kind of statement that they are put there?
They are. So I deliberately
use anyone.
I deliberately use certain types of symbols, certain shapes here, whereby an oval is conventional for start and stop. I used rectangles for any statement of code, like an assignment or a printing and so forth. And I used diamonds to represent questions that you might ask, conditions, as we've seen. If you're doing this for yourself, if you're just trying to make sense of your code and writing it down, you certainly don't need to use these formal symbols, but I tried to be consistent with some best practices. And in fact, let me come back to this same picture because this was the first version of our picture, but we've since modified our code a couple of times. This, recall, was the version where the question we were asking was I not equal to 0. Let me go ahead and just change this code now to represent the next version we did, which, recall, changed our logic to start counting from 1. It changed our question to check is I less than or equal to 3. But then everything else was the same except for the counting, which is now plus instead of minus. And then we refined it a little bit further by counting now from 0 up to, but not through 3. And we tightened up this code here by just incrementing 1 by using the slightly more succinct syntax. So at this point, these flowcharts might become less and less useful for us because once you've wrapped your mind around the concept, and hopefully the picture helps bring that concept to life, it's certainly fine to focus entirely on the code and only think about or even draw something like this if you need to wrap your mind around something more complicated than you're used to. Well, let me go ahead, if I may, and propose that we transition to another approach of types of loops using another keyword here, namely a for loop. And this is a word that does exist in other languages, but doesn't necessarily have as many features as other languages might use it for. But there is a different type of loop, not a while loop, but a for loop. And a for loop is going to allow us to express ourselves a little differently. But to do so, I'd propose that the easiest way is if we introduce one other idea in Python, which is that of a list. And here, too, no pun intended, we're adding to the list of data types that Python supports. We've seen strs or strings, ints or integers, floats or floating point values, bools or Boolean expressions. Python also has lists, which is another type of data. But wonderfully, this one's probably pretty familiar. A list of things in the real world is a list of things in Python. It's a way of containing multiple values all in the same place, all in the same variable. So what do I mean by this? Well, let me propose that we go back to our VS Code here, and let me kind of start fresh with my code here and not use a while loop at all, but let me use this new keyword for. The way the for loop works is that it allows you to iterate over a list of items. So what does this look like? It might look like this. For I in the following list of items: 0, 1, 2. This is my starting point, and on each iteration of this loop, that is, on each execution of this loop, again and again, I want to print out meow. Now, I'll admit, I kind of like the look of this code already, even though there's some new syntax here, because it's just shorter than the while loop, right? The while loop had multiple lines a moment ago, and it was entirely up to me to decide what I is. I have to check a condition. I have to increment or decrement I. Like, I was doing a lot of work, relatively speaking, to make that thing turn, to make that loop go and go. It was very mechanical in a sense. You can kind of, in your mind's eye, maybe see the gears turning as all of these variables are changing and these questions are being asked. A for loop kind of simplifies all of that. And it just says if you want a variable, like I, a number, and you know in advance how many times you want this loop to execute, 3 times, we'll just kind of specify what it is you want I to take on as values explicitly. In this loop, I will be automatically initialized by Python to be 0. Then meow will be printed. Then Python will automatically update I to equal 1. Then meow will be printed. Then Python will automatically update I to be 2, and meow will be printed. And because that's it for the values in that list, Python will stop, and it will only meow a total of 3 times. What is the list? The list in this program is exactly that, 0, 1, 2, and notice the square brackets. Those aren't parentheses. Those are square brackets that represent a list. That's how you know visually as the programmer. That's how Python knows as the language that you intend for that to be a list. So let me go ahead and run this, Python of cat.py, and it works just the same. But it's only 2 lines. It's pretty readable once you have familiarity with that construct. But to my constant point about correctness not necessarily being the same as design, in what sense is this program perhaps poorly designed? It seems to work. It meows 3 times. But why might this not be the best way to solve this problem? Even if you've never programmed before, again, think about corner cases, things that may or may not happen. Think about extreme cases that really test the quality of this code.
Okay, I think that because like we are saying 0, 1, 2 3 times, and then like if you want to print a million, you say 1, 2, 3.
Yeah, exactly. And that's what I mean about thinking about the extreme cases. If you're trying to decide for yourself if your own code is good or someone else's code is good, it might look so at first glance, but think about the extreme. Well, what if it's not 3 things? It's a million things. I mean, are you really going to write out 0 through a million or 0 through 999,999? Like, no, you're not going to write that many numbers on the screen. There's got to be a better way. So let's do the better way from the get-go rather than set the stage for doing something poorly. And the one way we can solve this problem to improve the design is don't just manually specify the list of values. Use a function. Someone else's function that comes with Python that gives you the list you want. And the easiest way to do that in Python is to use a function called range that returns to you a range of values. It expects as input at least 1 argument, and that number is going to be the number of values you want back. Those values are going to start at 0 and go to 1 to 2 and so forth, but they will go up to but not through the number you specify. So by specifying range 3, you're essentially being handed back 1, 2, 3 values. And by default, those values are 0, 1, and 2, and that's it. But what's brilliant about this is that now, to Hope's point, if I do want to meow a million times, I mean, that is an angry cat, I can now do a million by just typing a million. I don't have to literally type 0, 1, 2, 3, 4, all the way up to 999,999. I just do this. So that's got to be a better way long term. So that's indeed one improvement we can indeed make here, still using a for loop, but now using this range function. And just to show you something else that's Pythonic, this is not strictly necessary, but it's commonly done. There's a minor improvement we can make here, even if we're just meowing 3 times. And notice that even though I'm defining a variable I, I'm not ever using it. And it's kind of necessary logically because Python presumably has to use something for counting, right? It has to know what it's iterating over. But there's this convention in Python where if you need a variable just because the programming feature requires it to do some kind of counting or automatic updating, but you, the human, don't care about its value, a Pythonic improvement here would be to name that variable a single underscore, just because. It's not required. It doesn't change the correctness of the program, but it signals to yourself later, it signals to colleagues or teachers that are looking at your code too, that yes, it's a variable, but you don't care about its name because you're not using it later. It's just necessary in order to use this feature, this loop in this case here. So just a minor improvement or change there. But to really get you intrigued by what's possible in Python, let's take this one step further. So if we really want to be Pythonic, this one, if you've programmed before, is kind of going to blow your mind, so to speak, whereby if I want the cat to meow 3 times, what if I actually do this? Print, open parenthesis, quote unquote, meow times 3. All right, you have to be kind of a geek to think this is cool, but this is kind of cool. So you can literally just print what you want, multiply it by the number of times that you want it, and you will get back exactly that result. Now, I've kind of made a mistake here, so let's see what this does. It's not quite as beautiful as this code might look to you, to some of you, to me. Let me run Python of cat.py, enter. OK, it's a really like hungry cat or something. It's meowing really fast. But I can fix this, I bet. Let's think about now some of the basic building blocks we've discussed. The problem is clearly that literally meow, meow, meow is being repeated 3 times, but it's not as pretty as I want it. I want it to be meow, meow, meow on separate lines. What might be a possible solution here while still using this multiplication operator? And think back, we've used plus to concatenate strings. You can apparently use multiplication to concatenate strings, but more than once, again and again and again. How could I clean this up without reverting to my for loop or my while loop and still use multiplication in this way?
We can use the escape sequence, which should be \n.
Amazing. Yes, think back to \n, which is the way you as the programmer can express a new line in code. And I think if I take your advice, I put a \n there inside of my quotes so that at the end of every MEOW, there's a new line. Let's see how this looks. Let me clear my screen and run Python of cat.py. OK, so close. I like this. Let me call on someone else. The only thing I don't like, and I know I'm being really nitpicky now, is that it's meow, meow, meow on separate lines, but there's kind of this extra blank line, which I'm just not loving aesthetically.
I think we can make end equal to colon, not \n.
Yeah, so here too, like all of these things we've seen in past weeks are kind of coming together, right? Recall that the print function lets you control what the line ending is. By default, it's \n itself, which is why at the very end of this print, the cursor is being moved again to the next line. Well, we need to just override that. So let me go into my code here. And let me change this to comma end equals quote unquote so that it's no longer the default \n. It's instead now going to be nothing whatsoever. That should eliminate then hopefully that additional blank line. So let me run this one last time here, Python of cat.py, enter, and there we have it. So now, you know, at least as programming goes, it's kind of cool that I can distill this into a short line and express myself all at once. Now, to be fair, it's a little less readable. Like now I've got \n, I've got ×3, I've got end equals quote unquote. So you don't have to do things this way. My previous approach with a for loop, totally fine. My previous approach with a while loop, totally fine, and in some sense, perfectly well designed. But this is just yet another way to do it, but it's not a good thing if you or your teacher, your colleague, your friend are going to struggle to read your own code. But this is a feature of Python that some languages do not, in fact, have. All right, well, let me propose that things get more interesting still if we're not just meowing 3 times only, but we're meowing some variable number of times. Let's ask the user how many times this cat should meow. So let me clear the screen here, and let me figure out, well, how do I get a number from the user? The catch here is that if I want the user to give me a number, I'm not doing math per se, I'm meowing. And therefore, the user has to give me a positive value. The the user has to give me a positive value. So how can I insist on this? Well, if I just do this, n equals int of input, what's n, question mark. Well, I want to check, like I could say if n is less than 0, like if it's negative, well, I could do this. Well, then ask again, int input, what's n, question mark. OK, well, what if the user still doesn't give me a positive number? What if they're being really difficult, they're not paying attention, and they typed in 2 negative numbers? Well, if n is less than 0, well, let's do it again. N equals, right, this does not end well. You can't infinitely many times keep checking, is it negative, is it negative, is it negative, right? The program would never be done written. So we can do this, I think, better maybe with a loop. So let me propose this, a very common paradigm in Python when you want to get user input that matches a certain expectation you have, that it's all positive, that it's all negative, or just something like that. You just immediately say while true. You deliberately, and a little dangerously, but very conventionally, induce an infinite loop. Now, what is an infinite loop? It's just one that goes forever. And we've seen how that can happen accidentally, mathematically. It's absolutely going to happen when you say while true. Why? Well, the answer to the true question is always true. So this is a way of deliberately inducing a loop that by default is going to go forever. So we're going to need a way of breaking out of this loop when we have the number we want. The convention, though, inside of this otherwise an infinite loop is to ask the question you care about, like give me an int by prompting the user for input, like what's n, question mark, and then just ask your question. So if n is less than 0, then I think we want Python to just continue to prompt the user again. That is, we want the code to stay in the loop, recall the input function, and hope that the user gives us a better answer if this time around it's less than 0. So let's just literally use Python's keyword continue, which says just that, continue to stay within this loop. Else, if it's not less than 0, let's go ahead and just break out of the loop altogether using another keyword in Python, break. Break will break you out of the most recently begun loop. In this case, if it's not the case that n is less than 0. So this will work, and it will allow us to get a value that's 0 or greater from the user. But I think we can tighten it up further so as to not bother having an if and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0. So let's wait until they give us an integer that is greater than 0 and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here, so let me come back to that principle before, and let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going to go forever. But I'm asking a question inside of that loop. After getting an int from the user on line 2, I'm then checking, is it greater than 0? Or is it 0? Is it negative? None of which makes sense for a meowing cat. Like I want the cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once the user gives you a positive value, then we get to line 6, at which point we meow that many times because of line 6 and 7. So if I run this now, Python of cat.py, enter, well, what's n? Let's start with 3, where we began, meow, meow, meow. Well, this time, let me go ahead and increase the size of my terminal window just temporarily. Let me run Python of cat.py. Let me do it 10 times. Meow 10 times now appears on the screen. And the takeaways here are not just that we can meow 10 times or do something again and again, but this is a very common paradigm in Python when you want to do something again and again and again, but only until the user actually gives you a value that you care about here. And let me propose, actually, now that we practice a little more what we've been preaching, especially when it comes to, say, writing your own functions. You know, now that I'm doing all this meowing, it might be nice to actually have a meow function that the inventors of Python didn't envision. So let me do this. Let me actually get rid of all this code. And let me go ahead and do this. Let me go ahead and say define a main function, as I've done before. And let me just blindly call meow3. Meow doesn't exist yet, but when it does, that'll be great. So let me go ahead now and define meow. So my meow function should take as input a parameter called n or anything I want. And this part's pretty easy now. How do you meow n times? Well, for underscore in the range of n, go ahead and just print meow. So same code as before, nothing new here. I'm just putting that logic inside of a meow function that's going to have this side effect of printing meow. And now, as before, let me go down here and let me make sure I call main. And if I now run this code, Python of cat.py, meow, 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 it's always going to do 3 because I've hard-coded the 3. Well, let's make one improvement here. Let me go ahead now and maybe do this. Let me ask the user for a number. So let's say something like this. Number equals get number. All right, unfortunately, there is no function in Python called getNumber that gets a positive number from the user. But I can invent that. So define getNumber, open paren, close paren. And then inside of this function, let me do this. While true, go ahead and get a number from the user, converting it to an int, asking them what's n, question mark. And then if n is what I want, it's a greater than 0 value, a positive number. I don't want to break this time necessarily. Although I could, I instead want to return the value so I can actually do this instead. And this, too, is a feature of Python, this ability not to just break out of a block of code, but also to return a value in code. To actually return a value gives you the ability, ultimately, to return explicitly a value so that your function has not just a side effect necessarily, but it actually hands back, just like input does, just like int does, just like float does, an actual value to the user. Now, to be clear, I don't have to return n here. I can still break out of the loop, as I've done in the past with code like this. But then after the loop, I still have to return n. And so what's happening here is that if you use break to get out of the loop, but you need to hand back a value from a function, you still have to use the return keyword now explicitly, either in the loop as I did, or now outside of the loop, but still inside of the function. The last thing I'm going to do here now is change that 3, which we hard-coded earlier, to actually be the value of the variable we've gotten from the user, so that now down here, if I run Python of cat.py, enter, what's n? I can type in 3. I get my 3 meows. Or if I only want 1, I now get 1 meow instead. All right, so if we now have this ability to do things again and again in these loops, let's see if we can't solve some other problems via which to express ourselves cyclically, but get back some interesting answers as well. Let me propose, for instance, that we look a little more closely at these lists. It turns out that in Python, and really in programs in general, it's useful to have a list of values because we're going to be able to work with more and more data, larger and larger data sets. So let me propose that we come back to VS Code here, and let's do something that's perhaps a little familiar to some folks, the world of Hogwarts. And let me go ahead and code up a file called Hogwarts. And let's see if we can't have a list of students at Hogwarts here. So I have a new tab called hogwarts.py. And let me go ahead and propose that I just define in this program a list of students whose names I know in advance. So I'm not going to get user input for now. I'm just going to know from the get-go that the 3 students I want to consider are these. A variable is going to be called students. It's going to equal, as I've done in the past, a square bracket, which means, hey, here comes a list. And those values are going to be Hermione, in quotes, because it's a string. Harry, in quotes, because it's a string. And then Ron, in quotes, because it's a string as well. So this is a list of length 3. It's similar in spirit to my list of length 3 earlier, but that had 3 ints, 0, 1, 2. Now I have a list of 3 strings instead. And this isn't very useful at the moment, but let me just do something as a check for myself. Let me print out each of these students. Well, wait a minute. How do I print the contents of a list? Well, in the past, when we've printed a variable, we've just printed out the name of the variable. But I don't want to print out all of Hermione and Harry and Ron all at once. Maybe I want to print out Hermione first, then Harry, then Ron. So I need a way to express more precisely which value do I want from this list. And the way you do this in Python is you use square brackets in another way. If you have a variable, in this case called students, and you want to go inside of that variable and get a specific value, that is to say you want to index into the list, you use square brackets this way using numbers inside of the square brackets. And here's where we see that it is useful to think and count in terms of 0 on up instead of 1 on up. These lists in Python are, shall we say, 0 indexed. The first item in a list is at location 0. The second item in a Python list is at location 1, and the third is at location 2. So you're always kind of off by 1 mentally, but you get used to it if you've never programmed before over time. So let me print out all 3 students. So let me print out students bracket 0, then students bracket 1. Then lastly, let me print students bracket 2, and this is my third and final line. And of course, if I run this code, it probably does what you would guess. If I run Python of Hogwarts.py, there's Hermione, Harry, and Rob, each on their own lines there. But there's got to be a better way, right? Especially if I don't know in advance who's going to be in this list. If next year there's some new students at Hogwarts, we can use a loop to do something automatically without having to manually type out 0 and then 1 and 2. Well, here's another feature of Python. You can use a for loop, not just to count from 0 to 1 to 2. You can use Python to just iterate over anything, not just numbers, but strings. So I could actually do this. For student in students, colon, and then indented underneath that, I can say print student. Now, it doesn't matter if I have 3 students or 4 or 400. This 2 lines of code, this loop, will print all of those students for me one at a time. So if I now run Python of Hogwarts.py, there's the same list, but I don't need to know in advance how long that actual list is. Now, notice I made a conscious decision here. I didn't call this variable underscore, because this time I'm using the variable. And while I could do this, now, no. Your code is getting way too cryptic if you're naming the variable underscore and you're using the variable underscore. Now you're helping no one. Now you're confusing the reader yourself down the line. You should call your variables what they are. So a very appropriate name, though I'm sure you could come up with others, would be student. And here you would say student as well. If you'd prefer to be more succinct, it's not unreasonable to do something succinct in a loop like this. For s in students, using maybe the same letter that the list itself begins with. But again, why bother? Python is meant to be more readable. If you have a list of students, iterate over them 1 student at a time. Well, let me pause here to see if there's now questions about lists, as I've now defined them, a list of strings in this case, or using a for loop now to iterate over and print each of those names.
Yeah, so is it not necessary to initiate student in this case, or we can just declare a variable in the loop?
Good question. You do not need to manually initialize it. Python takes care of initializing the student variable to Hermione first, then Harry second, then Ron third. Unlike other languages, you don't need to initialize it to something yourself. It just exists and it will work. Other questions on loops and lists in this way?
Since you described break, so is there any concept of continue so that we can skip a particular case in loops?
Yes, you can continue using another syntax as well. We haven't shown that. For now, we focused only on break.
Okay, sure. Can this for loop work with either hash tables or different kind of iterables or arrays?
Indeed. So we're getting ahead of ourselves there, but there are yet other types of data in Python. And indeed, you can use a for loop to iterate over those as well. Anything that is iterable, so to speak, is a piece of data that can be used with a loop like this. But more on those soon. In fact, let me transition here to show just another way of solving this same problem, because up until now, when we've used loops, we really have relied on numbers, and that's fine if you prefer to sort of stay in that space. Suppose I did want to iterate using numbers like I and 0, 1, 2, and so forth. Let me propose that we could change this code as follows. If you would prefer to think about, or if the program you're trying to implement requires that you use numbers like this, you might do this. For I in, well, I don't want to just say students, because then I is not going to be a number. I is going to be literally Hermione, then Harry, then Rob. I need to iterate from 0 to 1 to 2, right? If I know a list with 3 elements, has these locations, 0, 1, 2, I need to create a loop somehow that starts at 0 and ends at 2. Previously, when I wanted to do that, I needed range, but this 2 is not going to work. I can't just say in the range of students, because students is not a number. It's not an integer, so you can't pass it to range. Range expects an integer. But there is a solution here. It turns out that there is a function in Python called length, or len, L-E-N, that will tell you the length of a list and other things down the line too. And now I think I can assemble these building blocks in a way that can allow me to use numbers in this way. So range doesn't take a list of strings, it takes a number. And ideally, that number is going to be 3, so I get a range of values, 0, 1, and 2. So I think I can nest my functions like this. If I first get the length of the students list, that's going to be 3. Then I pass that return value as the argument to range. That's going to give me back a range of values, 0, then 1, then 2. And what that's going to allow me to do then in code, if I want, is not just this. I could do print now students bracket I. And this is now where the syntax we're seeing is getting very expressive, new, and perhaps unfamiliar. But if I can do open bracket 0, close bracket, or open bracket 1, close bracket, or open bracket 2, close bracket, turns out I can actually put a variable in there. And I can express any number inside of those brackets so as to print these all out dynamically in a loop. Let me do this. Python of Hogwarts.py, enter. There's Hermione, Harry, and Ron. And now if I'm just curious, if I just want to poke around, or maybe I want to do a ranking, like who are the top 3 students in the school or in Gryffindor, well, I can print multiple things at a time, we've seen. Let me print out not just the students at location I, but rather let's print I first, and then the student at location I. So 2 things to print, and we know that print can take 2 arguments. We've seen that before. They'll be separated by a space. Let me go ahead and rerun this. Now I see that, OK, Hermione is the top student, but she's in 0th place. That's a little weird. Like, we don't need to show the human using my program that we started counting at 0. I can clean this up. I can just add 1 to the I up here. And now we see sort of a top 3 list of students. Hermione's number 1, Harry's number 2, and of course, Ron is number 3. So we can get access to all of those same values as well. All right, any questions now on these lists? Any questions now on these lists? This length, these ranges, or otherwise?
My question is, for I in range, can you explain this once more?
Sure.
Still looks cryptic.
So let me rewind in time. We started off doing this. For I in 0, 1, 2, and then we printed out meow 3 times in that way. The way that the for loop works is that it creates for you a variable that I've called I, but I could call it anything I want. It then assigns I initially to the first thing in the list. It then automatically assigns I to the next thing in the list. And then it assigns I to the third thing in the list. And each time, it does all of the indented code underneath. We realize, though, that this is not going to scale well if I want to do something like 1,000,000 times. So we introduced range instead. That has the effect of doing the same thing. It returns to me a range of values, a list of 3 things, really. So the behavior is exactly the same. If we now fast forward to this Hogwarts example now, though, what I'm doing is just combining these smaller ideas. I'm still creating a for loop. I'm still creating a variable called I. I want to do it over a range of values, but how many values? Well, if I use the length function and pass to the length function the list of values, length's purpose in life is to tell me how long is this list, and it's 3. So that's almost as though before I had just done something like this, but I don't want to hard code 3. I want to dynamically figure out how many students are at Hogwarts. So I'm just composing, or nesting all of these various ideas. All right, if I may, let me transition now to in Hogwarts still to introduce one final type of data before we combine everything with a few final programs. It turns out in Python, there's not just strings, not just ints, not just floating point values, not just bools, not just lists. There are also what are called dictionaries, or dicts, which are a data structure that allows you to associate one value with another. Literally a dictionary, like in the human world. If you were to open a dictionary, be it in English or any other human language, what's inside of a dictionary? Well, it's a bunch of words and definitions. A computer scientist, though, and a programmer would describe those more generically as keys and values. Something associated with something else. That's all a dictionary is. It allows you to associate something with something else. And notice, this is already more powerful, more interesting than a list. A list is just a set of multiple values. But a dictionary is sort of 2-dimensional, if you will, just like a human dictionary, a book. It associates something with something else, like words with their definitions. Now, what does this actually mean in practice? Well, suppose that we wanted to keep track of who is in what house at Hogwarts. Well, I could do it using lists alone. Let me go back to VS Code here, and let me just temporarily, but in a way that I'm not going to like ultimately, let me create another variable called houses, set it equal to Gryffindor, corresponding to Hermione's house, Gryffindor corresponding to Harry's house, and Gryffindor corresponding to Ron's house. And let's add Draco in there. So we now have 4 instead of 3 students, just so we have a little variety. And he was in Slytherin. So now we have 2 lists. And we could just agree amongst ourselves that whoever is first in the students variable lives in the first value in houses. Whoever is second in students lives in the second house. Who's ever third in students lives in the third house. We could do that. But honestly, that is going to break down quickly when we have a lot of students, when we have a lot of houses. And what if we want to keep track of more things than that? What if we want to keep track of every student's house and the Patronus, this image that they conjure up magically? Well, then we need a third list. Like, this is just going to get messy quickly if we're just on the honor system using multiple lists where everything lines up logically. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. A student with a house, a student with a house, a student with a house, and so forth. So how can I go about doing this? Well, let me go back to my code here. And let me propose that we do this using a Python dictionary. And this is the last of the new syntax, really, that we'll see. Here's the new syntax. Instead of using square brackets, we're going to use curly braces for dictionaries as well. We've seen curly braces in the context of F strings, completely unrelated. Sometimes you run out of keys on the keyboard and the authors of a language need to start reusing symbols in different ways. That's what's about to happen. We're using curly braces in a different way now. So let me create a variable called students, and let me go ahead and set it equal to open curly brace and close curly brace. This is an empty dictionary at the moment. And here's how a dictionary works. It allows you to associate something with something else. And you do that like this. Hermione, quote unquote, colon, and then the value thereof. What do you want to associate with Hermione? Well, Gryffindor. What do I want to associate Harry with? Well, I want to associate him with Gryffindor. What do I want to associate Ron with? Well, I want to associate him with Gryffindor. Well, this is actually not going to, this is going to get very ugly quickly. Once we add in Draco and Slytherin, my code is going to get too long. It's going to start wrapping. So this is purely aesthetic. It is perfectly acceptable in Python and other languages to format your code a little more readily and just add new lines if it makes it more readable. And one way of doing this might be as follows. I still have my curly brace up here. I still have my curly brace down here. But notice it's a little more readable now in that I have my keys on the left, my somethings, and my values on the right, my other somethings. It's just a little easier to skim top to bottom. You could format it differently as well. But I'm going to go ahead and add in now Draco, who lives, of course, in Slytherin. So now I have each of these keys on the left and values on the right, which is really, again, just a code implementation of this idea, a little chart that you might write up with paper pencil when associating something with something else. So how do I now use this code in an interesting way? The syntax is almost the same. If I want to print out the very first student, Hermione's house, I could do this. Print out the name of the variable, but I need to go inside of the variable. I need to index into it. And what's neat about dictionaries is that whereas lists have locations that are numeric, 0, 1, 2, Hermione, Harry, Ron, respectively, dictionaries allow you to use actual words as your indices, so to speak, your indexes to get inside of them. So if you want to print out Hermione's house, the key you care about is quote unquote Hermione. And what this syntax here will do, notice it's not a number 0 or 1 or 2. It's literally Hermione's name. This is like going to the chart earlier and saying, all right, give me Hermione is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print out Gryffindor. And if I do this a few times, students bracket, quote unquote, Harry should give me Harry's house. Print students, open bracket, Ron. That should give me Ron's house. And then lastly, if I do this with students, bracket, Draco, that should give me Draco's house. Now, it's a little manual still. I bet we can improve this, but let me run Python on Hogwarts.py, and we should see Gryffindor, 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 Slytherin, which is exactly what we'd expect. Now, all we've done again is we've just now moved from having just a simple list of names to, again, sort of 2 dimensions, associating, like we would on paper pencil, something with something else, keys with values respectively. allow me, if you will, even though I realize this is getting a little fancy, allow me to escalate things slightly here and transition from looking at just, for instance, that pattern there, just hard coding those values there, to actually printing these out more dynamically. Let me go ahead and use our loop. And this question came up earlier as well. Let me go ahead and say for each student in students, go ahead and print out, for instance, the student's variable at, well, let's just say student first. Let's keep it simple. So this is not going to be that interesting yet, but when I run python of hogwarts.py and hit enter, notice, what should I see? Let me take a question here to see, what am I going to see when I hit enter now, when I'm doing for student in students?
Yeah, I think we will only see keys.
Perfect. So good intuition. It could have gone both ways. Could have been values, the houses. But when you use a for loop in Python to iterate over a dictionary, by design, it iterates over all of the keys. So we should see, I think, Hermione, Harry, Ron, and Draco. Let me hit enter now. Enter. And indeed, you're exactly right. We see just the keys. But that's not really that useful if what I really care about is who lives where. Can I print out both? Well, I think I can. Let me go ahead and do this. Let me print out not just the student's name, the key, but let me use the key, their name, to index into the dictionary, right? If I know the word in the dictionary, let me look up its definition. If I know the student's name, let me look up their house. And the syntax for this, just like a list, is students, bracket, and just like in the past we used I, when I was a number, we can also, with a dictionary, use a string. So if the student's name is the key, then this syntax, students, open bracket, student, close bracket, will go to Hermione's location and get back her house. We'll go to Harry's location and get back his house, and so forth. So if I do python of hogwarts.py enter, now I see Hermione Gryffindor, Harry Gryffindor, Ron Gryffindor, Draco Slytherin. Now, it looks like I've given them all new last names, but I can clean that up. This is just a print thing. Let's go ahead and change our separator from the default space to maybe a space, comma. And just using print features now, let me run the same program again, enter. Now I've just got some nice pretty commas in there to make clear that Hermione's last name is not, in fact, Gryffindor. But that's just a print detail. Any questions then on these dictionaries and what I've just done? Questions on these dictionaries and this looping over them here?
I just can't get my head around the for student in students. Does if I'm just correct me if I'm right, does that mean it imports the list of students and uses the indexes, or in other words, Hermione, Harry, and Ron, as the indexes in the actual the list of students?
Correct. So this is just a feature of Python. When you use a for loop with a dictionary, what happens is this. If this is the dictionary here with the keys on top and the values on bottom, you get to choose what the variable is called. I called my variable student just because it makes sense, because I want one student at a time. And what the for loop does, just like it did with numbers before, the 0, the 1, and the 2, it allows me to, for instance, set student equal initially to Hermione's name. And then the next iteration of the loop, the next cycle, sets student equal to Harry's name, then Ron, then Draco. It just kind of happens automatically. Like that is what the Python interpreter does for you when it sees a for loop like that. So it's very similar in spirit to iterating with a for loop over a list, but rather than iterate over the numeric location 0, 1, 2, it iterates over the bold-faced keys in this representation here graphically. And allow me to give us one other example on Hogwarts before we look at one other familiar domain. At the risk of things escalating a little bit, let me propose that we continue the story with one final Hogwarts example like this. What if we have more information about each of our students? And this is kind of inevitable, right? If you're implementing a program that's a database with people or customers or employees or anything else, you can imagine having a lot of data about anything you're representing in your program here. For the sake of discussion, suppose that every student at Hogwarts, of course, has a name. They have already a house, but they also have a Patronus. For those unfamiliar, this is the animal or entity that comes out of the end of their wand when they make a certain magical spell. The point here being is that we want to associate not just one thing with the student, but multiple things as well. Their name, their house, and their Patronus in this case. Well, what might code like this look like? Well, let me go back to Hogwarts.py and let me start fresh for just a moment. And let me propose that I enhance this with a bit more data. And this data is going to look as follows. My students variable now, I'm going to propose we think of it as a list. What if we have a list of dictionaries as follows? Indeed, I want to literally implement this picture here. So notice that my previous picture just represented a single dictionary. But suppose I wanted to compose a list of dictionaries. That is, 4 students, so a list of 4 students. And suppose that each of those students is itself a dictionary, a collection of key value pairs, keys and values, something and something else. Well, here's one other way we can do this in code. Let me go back to VS Code here, and let me define a variable called students that is equal to a list. And I'm going to preemptively move my cursor onto separate lines because I know this is going to be long, and I want to fit all of the elements of this list inside of it. I'm now going to create a dictionary, 1 dictionary per student. And how do I create a dictionary? I just use those curly braces. But it's up to me to define what those keys are. And let me propose that 1 key this time won't be the student's name explicitly. It will literally be the word name, and they're going to have the name Hermione. This same student is going to have another key called house, and the value is going to be Gryffindor. And this same student's going to have a third key called Patronus, and the value of that is going to be, I had to look it up, an otter, according to the book. Now I'm going to create a second dictionary inside of this list. And again, a dictionary is like literally like the human dictionary of words. It's a book that contains keys and values, words and definitions. What are the 3 words I'm storing in each of my dictionaries? Name, house, and Patronus. What are the definitions of those words for Hermione? Hermione, Gryffindor, and Otter, respectively. For Harry, the definitions are going to be different in this new dictionary. Let me give myself another pair of curly braces and say this. Name, quote unquote, colon, Harry. House here is again going to be Gryffindor. And this one I knew, his Patronus is going to be, in this case, a stag. All right, next, a third dictionary. The name here will be Ron. And I'm going to go ahead and do that just like this. Next, I have the house, and he too was Gryffindor. Lastly, had to look this one up, Ron's Patronus was a Jack Russell Terrier. Lastly is Draco in a 4th dictionary now, so another pair of curly braces. The name of this student is, of course, Draco. The house of this student is Slytherin. And Draco, interestingly enough, at least according to the internet, has no Patronus, was never revealed in the books or the movies. So it turns out, this is actually a wonderful teachable moment, there is a special keyword in Python that is literally none, N-O-N-E, with the first letter capitalized. This represents officially the absence of a value. So I could a little sloppily do something like quote unquote, but does that mean I didn't get around to typing it or not? It's a little clearer semantically to say literally none, a special keyword in Python to make clear that I know Draco has no Patronus. It's not just an oversight on my part. Now that I have this, what do I have in the computer's memory? I have a list. How do I know it's a list? Because I see a square bracket at the beginning and another square bracket at the end. That's just my visual clue. OK, I don't know necessarily what else is going on here, but there's a list of something. What is in that list? Well, here too, the syntax is our clue. Because this line 2 starts with a curly brace and ends with a curly brace, I just know that is a dictionary, a collection of key value pairs. Now, this all fit on my screen perfectly, so I didn't bother moving all of the key value pairs onto new lines. It would have made it really tall, so I kept it all together here this time. But how many keys does this first dictionary have? Put another way, in Hermione's physical dictionary, how many words are in that dictionary? 3. The words are name, house, and Patronus. What are the 3 definitions or values of those words in Hermione's dictionary? Hermione, Gryffindor, and Otter, respectively. And the same story goes for Harry, then for Ron, then for Draco. I have, by design, chosen to give them dictionaries that have all the same keys, all the same names, but they all have unique values. And that's my design. That's my prerogative as a programmer. So why is this useful at the end of the day? Now I have access to a whole collection of interesting data about all of these students. And I can still do a loop. I can say for student and students, that's going to allow me to iterate over this list of students. And let me go ahead and print out just one thing at a time. Let me print out the current student's name. So as complicated as the dictionary is, this should be pretty comfortable. For student and students is just going to iterate over every student in the list. 1, 2, 3, 4 total. The next line is just going to print out the value of the name key. It's like opening a physical dictionary, looking up the word name, and giving us Hermione, Harry, Ron, and Draco respectively from each dictionary. So if I run this version of Hogwarts and hit enter, there, I get all 3 of their names. But what if I want more information than that? I want both their names and their houses. Well, just add to print's arguments, student, open bracket, house, close bracket. All right, let's go ahead and run this. Python of Hogwarts.py and hit enter. So I now see Hermione Gryffindor, Harry Gryffindor, and so forth. Well, we can aesthetically clean this up a little bit by adding a separator with print, like a comma and a space, just so that when I run this again, I now see some commas separating these values. But recall that students have not just a name, not just a house, but also that Patronus. So if we want to print out that too, we now have the syntax via which to go into that same dictionary for each student and output their Patronus as well as their house and their name. So if I run this program one final time, now I see all of the data in this here dictionary. So this is a lot to absorb all at once, I'm sure. It's the last of our new data types. On top of lists, we have these dictionaries. But again, a dictionary at the end of the day is just a collection of values similar to these values here that allow you to associate keys with values. And the first version of this program associated literally the students' names with their houses. But then I realized in my next version, wait a minute, what if every student has not just a name and a house, but a Patronus? Let's actually standardize the names of our keys to be name, house, and Patronus. And then the values of those keys can actually be the data, like Hermione, Gryffindor, Otter, and so forth. Questions now on these dictionaries and iteration thereof?
I just was wondering if suppose the dictionary is very huge, and if I want to look up for a specific student, so how do I know where to look that student from? Like, can we sort it out in alphabetical order or numeric order or anything like that?
In short answer, yes. One of the features of Python is that it makes these dictionaries very highly performant for you. That is, even if they're very large, as they will be in future weeks when we manipulate more data, Python will find the data you care about quickly for you. And in fact, that is a feature of the language. That is a feature of a dictionary to get you the data quickly. And there are functions that you can use. You can sort the data. You can sift through it. You can do very performant operations, as we eventually will. Allow me then to propose, as we wrap up these loops, that we solve just a few final problems that will perhaps evoke fond memories of yesteryear, at least for me, wherein one of my favorite games growing up was this one here on the original Nintendo. And this is a two-dimensional world where the characters move up, down, and right, not so much to the left, in jumping over pyramids and obstructions like these. And allow me to propose that we use this just for inspiration, not to do something that's quite as colorful or graphical as this, but just to focus on, for instance, this barrier in the middle of the world here that Mario or Luigi had to jump over. And so this here seems to be like 3 bricks stacked on top of one another. And we won't do things quite graphically, but let's just implement a very simple Python-based version of this textually using maybe